I am Mrs. A. R.V.K. Mary, Assistant Professor, PG and Research Department of Mathematics, St. Joseph's College of Arts and Science, Autonomous, Cuddalore. Today we are going to see what is triple integral and how to evaluate it. Let f be a function of three variables x, y, z. It is continuous function defined at any point of the region enclosing a volume V. Divide the region into a number of subregions of volumes delta V1, delta V2, etc. delta Vn. Let xr, yr, zr, where r equal to 1 to etc. n, be n interior points of delta Vr. Let limit n tends to infinity Sn equal to limit n tends to infinity summation r varies from 1 to n f of xr, yr, zr into delta Vr such that delta Vr tends to 0. Then, if this limit exists, it is called the triple integral. It is triple integral of x, y, z over v, and it is denoted by triple integral over v f of x, y, z dv. This integral is expressed of the form integral z1 to z2, integral y1 to y2, integral x1 to x2, f of x, y, z, dx, dy, dz. The evaluation of this integral is done as follows. Suppose x1, x2 are functions of y and z. Y is function of z. Then the limits for z1 and z2 are constants, say a and b respectively. Then we can write integral a to b, integral y varies from phi1 of z to phi2 of z, and x varies from f1 of yz to f2 of yz, f of xyz dx, dy, dz. That is, we evaluate with respect to x first, followed by y, and then followed by z. Suppose z1 is function of xy and z2 is function of f2 of xy, y1 is function of x, that is phi1 of x, y2 is phi2 of x, and the x1 is constant, that is x is constant, x1 is a and x2 is b. Then we can write as integral a to b, y1 varies from phi1 of x to phi2 of x, integral z1 to z2 is f1 of xy to f2 of xy, f of xy is z. Then here the integral is done with respect to z first, followed by y, and then with respect to x. If y is given as function of xz, z as function of x, and x as constant, then the integral is done as integral a to b, integral phi1 of x to phi2 of x, then integral f1 of xz to f2 of xz, f of xyz. Here the integral is first done with respect to y first, then z, and then with respect to x. Suppose all the limits are constants, then the integration can be done in any order. Let us see example. Now evaluate integral 2 to 4, 0 to x, 0 to root of x plus y, z, dz, dy, dx. See here, the limit for z is given as function of xy, root of x plus y. So we integrate with respect to z first. And limit for y is given as function of x, 0 to x. So we integrate with respect to y, and then we integrate with respect to x, because the limit for x is constant. That is, let I equal to integral 2 to 4, 0 to x, 0 to root of x plus y, z, dz, dy, dx. First we integrate with respect to z. For z, the integration is z square by 2. Z square by 2. The limit is 0 to root of x plus y, then dy, dx. Now apply the limit, that is integral 2 to 4, integral 0 to x. For z it is root of x plus y. For z square, root and square gets cancelled. So we get x plus y by 2 and dy dx. Now for x 1 by 2 can be taken out. For x it is integral dy is y. So x into y. For y it is y square by 2. Limit is 0 to x, then dx. Now apply the limit for y. So x into x, x square plus x square by 2. Okay. So now it is for, we can simplify this. Okay. This is 3 by 2 x square. So 3 by 4 x square. 3 by, now for x square the integration is x cube by 3. 3 gets cancelled. So we get 1 by 4 into x cube. Limit is 2 to 4. The upper limit is 4 cube minus lower limit is 2 cube. That is 64 minus 8. So we get the answer as 14. Just see one more example. Here it is given in terms of r and theta. Integral 0 to pi by 2, integral 0 to a cos theta, integral 0 to root of a square minus r square, dz, dr, d theta. This, let I equal to, take it as I. Now we have to integrate with respect to z first because it is given in terms of r. Okay. So it is integral dz is z, 0 to root of a square minus r square. When you apply it, we get root of a square minus r square dr d theta. Okay. And then integral root of a square minus r square is r by 2 root of a square minus r square plus a square by 2 sine inverse of r by a. Limit is 0 to a cos theta. Apply the limit. When you apply the limit, a cos theta, so a cos theta by 2, a square minus a square cos square theta, that is a square minus a square cos square theta is a square into sine square theta. So root of it is a sine theta. Okay. And a cos theta, if you apply here, sine inverse of a cos theta by a, that is sine inverse of cos theta. Okay. And then the lower limit is sine inverse of 0, that is 0. So let us calculate this, sine inverse of a cos theta. Sine inverse of cos theta, see, sine inverse of a cos theta by a, so a gets cancelled. Sine inverse of cos theta is sine inverse of, let us write this cos theta in terms of sine theta, that is sine pi by 2 minus theta. Sine inverse and sine gets cancelled and the value is pi by 2 minus theta. So we get here a square by 2 into pi by 2 minus theta. Now it is integral 0 to pi by 2. Okay. Sin theta cos theta is sin 2 theta divided by 2. So a square sin 2 theta divided by 2 into 2, 4. Then plus a square pi by 4 minus a square theta by 2. Now integrating this we get a square by 2. For sin 2 theta the integration is minus cos 2 theta by 2. A square pi theta by 4 minus a square by 2. For theta it is theta square by 2. So it is theta square by 2 into 2, 4. Limit is 0 to pi by 2. We get cos 2 into pi by 2. Cos pi is minus 1. So minus of minus becomes plus a square by 8. A square pi by 4 into, for theta it is pi by 2 minus a square by 4 into theta square is pi square by 4. And the plus lower limit when you apply, cos 0 is 1. So we get plus a square by 8. Simplifying this, a square by 8 plus a square by 8 is a square by 4. And this is pi square a square by 8 minus pi square a square by 16. Again this is pi square a square by 16. So taking LCM we get a square by 16 into 4 plus pi square. Thank you.